The story of the formation and evolution of the universe has paralleled the tremendous progress we've made with space exploration instruments. With the Hubble Space Telescope, we've learned that stars, galaxies, and supermassive black holes existed far earlier in cosmic history than anyone expected and that they have since undergone radical change. We've learned that dark matter and dark energy sculpt the cosmos. With the Keck telescope and others, we've seen that all manner of planets decorate galaxies like baubles on Christmas trees, including billions of potentially habitable worlds in our Milky Way alone. And now, with the arrival of James Webb, we are peering deeper into space to see an unknown universe, from exoplanets to supermassive black holes to the first stars and galaxies. Webb is showing us the universe as we've never seen it before. 2 years since it went into operation, James Webb has changed how we view the cosmos. The most stunning images it released so far and what it's taught us about the universe that had so far remained out of reach. Join us as we dig deep into how James Webb is rewriting our cosmic star formation history. When we tell the history of star formation in the universe, it normally proceeds as follows. At the very beginning, there are no stars at all. As protons and neutrons, and then atomic nuclei and neutral atoms form, it takes tens or even hundreds of millions of years for these pristine clouds of gas to gravitationally grow massive enough so they can collapse. And when they do, they trigger the formation of the first generation of stars. Stars initially made of hydrogen and helium alone, but then the first generation of stars dies, including many of them. Instead, stellar cataclysms like supernovae and all of the nuclear reactions that occurred within that star, the slow-burning fusion reactions that occurred in the star's core during its lifetime, plus the rapid reactions that occur during a cataclysmic event, are cumulatively reflected in the material returned by that former star to the interstellar medium over time. That enriched ejected material then mixes with the remainder of the interstellar medium, which serves as a great cosmic recycling system. From that now enriched interstellar material, new generations of stars will form, with the interstellar medium gradually getting more progressively enriched with time. This is interesting from the perspective of learning how the universe and the stars within it evolved and grew up from early times until the present day. We exist today in the here and now, but the stars that we can see aren't only the stars that are forming right now. They're all the stars formed throughout the universe's history that are still burning and shining with respect to our observing perspective. If our goals include gaining an understanding of the earliest stars in the universe, we have a couple of options. We can look to the greatest distances possible and try to detect the earliest stellar populations back at the epochs when those stars were just in the process of forming, or we can look around us nearby at the oldest, most pristine relic stars that we can find and try to learn what the universe was like at the time of their formation by examining their properties today. The James Webb era has given us an incredible wealth of data about the early universe. Less than 2 years after its launch, James Webb has transformed humanity's view of the cosmos, peering into dust clouds and seeing light from faraway corners of the universe for the very first time. Every new image is a new discovery, empowering scientists around the globe to ask and answer questions they once could never dream of. The world of astronomy has been dazzled, knowing that among the objects caught in the telescope's giant mirror is one that turns out to be the oldest known galaxy in the universe. The prosaically named J's early universe, GZS 13, appears as it did a mere 320 million years after the Big Bang, long before the creation of our own planet. It also turns out to be tiny compared with our own galaxy, but it was clearly creating new stars at a rate comparable to the Milky Way. Intriguingly, this stellar fecundity is shared by several other ancient galaxies photographed by James Webb. These snapshots of the infant universe show that the first stars and galaxies had already formed and were evolving much earlier than most scientists had expected. As Professor Brant Robertson, an astrophysicist at the University of California, Santa Cruz, said, "These galaxies are very, very young, yet they have already become hotbeds for star formation. It's remarkable." This enthusiasm was shared by Kevin Handline, an astronomer at the University of Arizona, Tucson. According to Kevin, "We have observed the earliest galaxies in the universe, and it has been thrilling. It has opened an entirely new chapter in the history of astronomy. It is telling us the universe was dynamic from the beginning. And the photographs of the Aro-Gyuchi starfield are certainly stunning." However, the far more muted images of JA's GZS-13 and its ancient partner galaxies are causing real excitement among cosmologists and astrophysicists. It is argued that more than any other set of observations, they underline the true potential of the James Webb Telescope. As Sandro Ticella, a Cambridge University astrophysicist, said, "What is so surprising is the detail of the early universe that it has revealed." Theory predicted that very complex cosmological processes would be occurring at this time, though I did not expect to be able to observe them. However, the telescope takes such magnificently sharp images, we can actually see this complexity in operation. It was surprising and very gratifying. What's more interesting is James Webb's glimpses of early galaxies could shed light on dark matter. Dark matter is a mysterious, invisible form of matter that is thought to make up about 27% of the known universe, outweighing visible matter about 6 to 1. Still, despite making up a considerable chunk of the universe, it has eluded our understanding since its existence was first suggested in 1933 by Fritz Zwicky, a Swiss-American astronomer. To date, dark matter has never been directly detected. While the James Webb Space Telescope cannot directly see dark matter, scientists think that by measuring the effects it has on its surrounding web could answer some major questions about dark matter. This, in turn, would greatly advance our knowledge of the universe at large. Chief among them is how exactly dark matter guided the emergence of galaxies. For the first few 100,000 years after the Big Bang, the cosmos was so hot that gravity could not pull normal matter together to form large protogalactic clumps. But this, according to Jordi Penarrua, a cosmologist at the University of Edinburgh in Scotland, was not an issue for dark matter because dark matter does not interact via electromagnetic forces. Instead, gravity alone is this invisible substance's master, meaning that in mere moments after the Big Bang, when primordial chaos reigned, gravity immediately began gluing together dark matter into large clumps known as halos. These dark matter halos are believed to have acted as gravitational sinks for normal matter, seeding the subsequent formation of galaxies in the early universe. The telltale motions of the stars they shepherd betray their endurance to this day. Such halos still surround galaxies like our own, majestic but invisible sculptures of the modern cosmos. James Webb's rapid discovery of early galaxies might be testing our understanding of how these halos form, perhaps suggesting they reached an immense bulk earlier than expected. One explanation might involve the very nature of dark matter itself. Theorists have found that simple treatments of dark matter, in which it only interacts with itself and normal matter via gravity, can accurately replicate large-scale cosmic structure. But nature has no guarantee of simplicity. In reality, dark matter could interact with itself because of an as-yet unknown force, perhaps via a particle that's not in the current standard model of physics, possibly increasing the speed at which these halos grew and explaining how big, bright galaxies were able to arise so quickly. In short, although there are other possible ways for cold dark matter to end the crisis caused by Webb's impossible early galaxies, one appeal of studying alternative dark matter models is the possibility of finding new phenomena that can be observationally tested. In this specific case, James Webb just might be up to the task of finding and studying some of the universe's earliest dwarf galaxies, making comparisons between model-based predictions of their size, shape, and chemical composition to reveal which flavor of dark matter actually prevails. The key will be linking James Webb to far larger cosmic telescopes called gravitational lenses. Despite their fancy name, these are merely galaxy clusters so hefty that the mass-warped spacetime around them amplifies the light from background objects. Using James Webb to look through suitable gravitational lenses, luckily aligned with far-distant background galaxies from the early universe, astronomers just might glimpse the glow from small primordial satellite galaxies, and with it shed light on dark matter's still mysterious true form. In addition, James Webb also spent a heavy investment of its precious observing time focusing on mysterious structures lurking in vast space. In the latest observation, the Webb telescope has seen Beta Pictoris as never before, capturing a previously unseen structure that gives the young planetary system a dusty cat's tail. Located 63 light-years away from us, Beta Pictoris is a star around twice the size of the Sun and 8 times as bright, surrounded by a disk of gas and dust in which there is evidence planets have formed. Beta Pictoris was the first planetary system around which astronomers spotted a dusty disk of material composed of debris caused by the collision of asteroids and planetesimals during the system's violent formative years. Following this, using the Hubble Space Telescope, astronomers spotted a second disk of debris and material in the Beta Pictoris system. Now, using James Webb instruments, the NCAM and MIRI, a team of astronomers has discovered another layer of structure in the system, in the form of a sharply inclined branch of dust extending from the southwest portion of the secondary debris disk. According to study team leader Isabel Rebelo, a scientist at the Astrobiology Center in Spain, Beta Pictoris is the debris disk that has it all. It has a really bright close star that we can study very well. While there have been previous observations from the ground in this wavelength range, they did not have the sensitivity and the spatial resolution that we now have with the James Webb Space Telescope, so they didn't detect this feature. The cat's tail of Beta Pictoris only appeared to the MIRI instrument because it is shining most brightly in mid-infrared light, perhaps also explaining why it had been missed before. In addition, Rebelo and her team also noticed another feature of Beta Pictoris. They saw a temperature difference between the two disks of the planetary system, which indicates they may have different compositions. As research co-author Christopher Stark of NASA Goddard Space Flight Center in Maryland said, "We didn't expect the James Webb Telescope to reveal that there are two different types of material around Beta Pictoris, but MIRI clearly showed us that the material of the secondary disk and cat's tail is hotter than the main disk. The dust that forms that disk and tail must be very dark, so we don't easily see it at visible or near-infrared wavelengths, but in the mid-infrared, it's glowing." The team theorizes that the disk with the hotter temperature is comprised of dark, highly porous material that is similar to that seen at the surface of comets and asteroids in our solar system, which is known as organic refractory material. While animal behavioralists think cats put a crook in their vertically extended tails as a greeting or to indicate friendliness or playfulness, Rebelo and colleagues aren't sure what gives this cosmic cat's tail its shape. This curved feature isn't something that is seen in the disks of material in other planet-birthing systems. To unravel this cat's cradle of a puzzle, the team modeled several scenarios to try to recreate the cat's tail structure and thus explain its origins. However, the cat's tail feature is highly unusual, and reproducing the curvature with a dynamical model was difficult, explained Stark. Our model requires dust that can be pushed out of the system extremely rapidly, which again suggests it's made of organic refractory material. This investigation led the team to determine that the cat's tail had likely been caused by a dust-producing event that occurred only around 100 years ago from our perspective here on Earth. As research co-author Marshall Purr of the Space Telescope Science Institute in Baltimore said, "Something happens, like a collision, and a lot of dust is produced. At first, the dust goes in the same orbital direction as its source, but then it also starts to spread out." Purr added that the light from the star pushes the smallest, fluffiest dust particles away from the star faster, while the bigger grains are tougher to shift and thus do not move as much, which creates a long tendril of dust. As for the sharp angle at which the dust tail juts away from the debris disk, Rebelo and colleagues think that this is a mere optical illusion caused by the angle at which James Webb observed Beta Pictoris. The actual angle at which the dust trail extends from the debris disk is just 5 degrees. Accounting for the brightness of this newly discovered feature, the astronomers were also able to determine that the dust in the tail is equivalent to the mass of an average asteroid in the main belt between Jupiter and Mars being spread out to a length of around 16 billion kilometers. The dust creation event that gave Beta Pictoris its feline feature may also be responsible for another curious characteristic of the system. The researchers think the same collision may be the cause of an asymmetry in Beta Pictoris previously observed in 2014 by the Atacama Large Millimeter/Submillimeter Array. This asymmetry takes the form of a clump of carbon monoxide which sits by the cat's tail. Because radiation from the central star should take no longer than a century to break down this carbon monoxide clump, the fact that the concentration of gas still lingers could be evidence of the same event. Stark concluded that our research suggests that Beta Pic may be even more active and chaotic than we had previously thought. The James Webb Space Telescope continues to surprise us, even when looking at the most well-studied objects. We have a completely new window into these planetary life systems. Next, let's address rumors that have been circulating in respectable corners of the astronomy and astrobiological community, suggesting that the James Webb Space Telescope has found a planet with strong evidence of life. Some of this sentiment bubbled into the public view when the British news magazine The Spectator published an item titled, "Have we just discovered aliens?" The Spectator featured comments by some serious British scientists, including astrophysicist Rebecca Smithist, who said, "I think we are going to get a paper that has strong evidence for a biosignature on an exoplanet very, very soon." Additionally, there was British astronaut Tim Peake fanning the flames with this comment, "Potentially the James Webb Telescope may have already found alien life. It's just that they don't want to release or confirm those results until they can be entirely sure. But we found a planet that seems to be giving off strong signals of biological life." But according to Nicole Colon, the telescope's deputy project scientist for exoplanet science, the James Webb Space Telescope has not found definitive evidence of life on an exoplanet. It is anticipated that James Webb observations may lead to the initial identification of potential biosignatures that could make habitability more or less likely for a given exoplanet. Future missions will be needed to conclusively establish the habitability of an exoplanet. It's an answer worded to tamp down any out-of-control rumors, but it certainly leaves the door open to some exciting possibilities. While a lot of the hype may be overblown, at the very least, the speculation reflects the Space Telescope's extraordinary promise in the field of exobiology. The hype, elevated by the near-mythic capabilities of the James Webb, stems from the telescope's detection of a potential biosignature on the exoplanet K2-18b last year, a suspected ocean world around 8.6 times more massive than Earth and approximately 120 light-years away. Astronomers believe this may be a lean exoplanet, meaning it has water oceans on its surface and a hydrogen-rich atmosphere. Astronomers had previously studied this planet with the Hubble Space Telescope, but their interest was magnified when the Webb telescope, which became operational last year after launching in late 2022, made some intriguing observations. Among the molecules found by Webb was dimethyl sulfide. So, what is dimethyl sulfide? It's an organic compound that you may have smelled if you've ever cooked cabbage. It is emitted by phytoplankton in Earth's oceans as part of their metabolic process. Critically, on Earth, dimethyl sulfide is only produced by life. That does not prove the existence of life on K2-18b, but if dimethyl sulfide exists there, it is certainly a hair-raising clue. However, note that the evidence, as Colon said, isn't definitive. More observations, perhaps with entirely new instruments, will be needed to confirm the detection. Moreover, it's possible that dimethyl sulfide can be produced without life. Understandably, scientists don't want to jump the gun, as a long history of extraterrestrial hoaxes and spoofs have haunted the field. All those caveats aside, it hasn't stopped many in the community from being hopeful. In short, the full story has yet to be told. If this discovery were the movie Star Wars, we're at the point where Luke Skywalker just rode into Mos Eisley in a landspeeder. There's a lot of story to go before he blows up the Death Star and saves the rebellion, or finds alien life. The reality is that science is rarely as intuitive or as fast as we would like it to be. But it eventually gets to the truth. So, let's try to enjoy the ride. As a piece of good news, NASA's Earth-like exoplanet transiting exoplanet survey satellite, or TESS, has just discovered an extraordinary planet that's roughly the size of Earth, but is only 1/10 of our planet's age. With half of its surface likely dominated by scorching hot lava, the exoplanet orbits a sun-like star called HD 63433, which is located 73 light-years from Earth at a proximity of around 12% the distance between Mercury and the Sun. This is so close that the planet, designated HD 63433d, completes an orbit in just 4.2 Earth days. Because of this proximity to its star, which has 99% the mass of our Sun, the planet is tidally locked, just like the Moon is to Earth. This means that one side of the planet, its day side, constantly faces the star and is permanently blasted with stellar radiation, while the cooler night side perpetually faces out into space. NASA officials said that this pushes surface temperatures on the planet's day side up around 1,160 degrees Celsius. The violent temperatures of HD 63433d mean that the planet's day side is likely a hemisphere of blisteringly hot lava, resembling that of exoplanets like Corot 7b and Kepler 10b. However, this exoplanet is also remarkable for a slightly less extreme reason than its lava-dominated day side. It is also the smallest, confirmed exoplanet that's less than 500 million years old. In addition to this, at 1.1 times the diameter of our planet, HD 63433d is the closest roughly Earth-sized planet to be discovered that is less than 400 million years old. For comparison, Earth and the rest of our solar system are around 4.5 billion years old, meaning HD 63433d appears to be just around 10% of the age of our planet. The Earth orbiting test discovered HD 63433d as it crossed, or transited, the face of its star, causing a slight dip in light from its stellar parent. TESS, which launched in April 2018, has used this transit method of exoplanet detection to spot over 4,000 alien worlds, of which several hundred have been confirmed. This isn't the first planet to be discovered orbiting HD 63433. The existence of sibling worlds prompted further investigation of the system. In 2020, the transit method uncovered HD 63433b and HD 63433c. The former is a roughly Neptune-sized planet, around 2.1 times wider than Earth and roughly 5 times more massive. HD 63433b orbits its star at 0.07 times the distance between Earth and the Sun, with a year that lasts 7.1 Earth days. HD 63433c is slightly larger, around 0.23 times the size of Jupiter, with a mass around 7 times that of Earth. This world takes a relatively leisurely orbit of 20.5 Earth days around its star, dwelling at a distance 0.14 times that between Earth and the Sun. The unique features of HD 63433d make it a primary target for subsequent investigations that will aim to further study both the day and night hemispheres of this world. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.